Okay, moving on to example 2 here. The depth in meters of water in a seaplane harbor on a given day can be modeled using this function, where t is the time past midnight in hours. So notice how we have our variables being defined here, so we know exactly what it is that we're talking about. Determine the maximum and minimum depths of the water in the harbor. So we talked about this in our last video. Your axis of your curve plus your amplitude would be your maximum, and your axis of your curve minus the amplitude is your minimum. So you can calculate those. So max would equal your axis of the curve plus the amplitude. So that's going to be a 26 meters. So the maximum depth is 26 meters. And your min would be the axis of your curve minus your amplitude, which is only 2 meters deep. So that water comes in and out, and that almost looked like a 76 there. That's a 26. What's the period of the function? So that comes from the k. The period is equal to 360 divided by the k value. So in this case, it's 360 divided by 30. Okay, and 360 divided by 30 is equal to 12. So the period is 12, and that goes with our independent variable, which is t, and that's time in hours. So the period is 12 hours. Okay, period is 12 hours. All right, sketch a graph of the water level over 24 hours. So 24 hours then would be 2 periods worth. And I need to have a minimum of 2 and a maximum up here of 26. And this is just a sketch. So that's my height, or depth of water, I should say. Okay, and from there I need a period of 12 hours. So 12 divided into 4 equal parts would be 3. So I'm going to make a scale go up by 3 here. So whatever my period is, I just take the period and divide it by 4 to help me get that horizontal scale to be whatever will work nicely. Okay, so one cycle should fit over the 4 parts there. From there, I'm going to keep going with another set of 4. 1, 2, 3, 4. So this would be 24 hours to get 2 cycles in there. 24 hours. So this is our time in hours and our depth. Sine normally starts on the axis of the curve, which would be at the 14. So let that be y equals 14. Sort of halfway between my max and my min. And I'm going to slide everything over by 5 units. So normally I'd be on the y-axis on the axis of the curve, but instead I'm over by 5 units. So this would be where 5 is. And I'm going to head up from there. So my max should happen at 8. My min is going to happen, my axis of the curve, back to the axis of the curve would be at 11. 12, 13, 14, 15. So at 14, I should be down at the minimum. And then back on the axis of the curve at 17. So that would give me 1 full cycle right there of the depth based on that equation. Okay, so you can do it through transformations, or you can just use your actual characteristics there to come up with our values. And then I'm just trying to extend that curve back to a place like that. Okay, so 24 hours, I need to just keep going 1 more cycle with that. So I should be up at the maximum here. Whoops, I don't know how I keep making my screen move. I'm sure there's a definite reason on how I'm doing that, but I think I accidentally touch it sometimes and then I'm touching it in 2 spots instead of just with the stylus. Okay, so there's a good 24-hour span plus. If the water is less than 3 meters deep, the landing a seaplane would be considered unsafe. During what time intervals between midnight and midnight the following day is it considered unsafe? So midnight is happening here at 0, and 3 meters would be like somewhere around here. Okay, so over that 24-hour period, you can see it happens 4 times, or it's like between here and here, whatever that happens to be, that value, and between here and here, whatever those time values are. So let's solve this like an equation. I'm going to let my depth be the 3, and we're going to solve for t. And remember, we're going to use the cast rule to help us get a second answer with that when we get there. Okay, first step, we're going to undo the plus 14 by subtracting 14. So 3 take away 14 would be negative 11. So we're going to have a negative 11 here, and that's equal to 12 times the sine of this thing, which would be the actual angle if we were working with angles. So I'm going to divide the 11 by 12, the negative 11 by 12, and I got negative 0.91, 0.916, repeating again. And that's equal to the sine of the 30, t minus 5. And then we're going to undo sine by second function sine on that negative 0.916 repeating, and I got a negative 66.44, roughly equaling 30 t minus 5. Okay, so sine is negative in 2 quadrants. I'm just going to slide this up here to keep it out of the way. So I've been given my answer in this quadrant. That's my negative 66.44. Sine's also negative here. I'm going to have 180 plus that 66.44 as another possible answer there. So 180 plus 66.44. I'm going to take that and add 180, and I get 246.44. Okay, so we get this, or we get 30 times t minus 5 being equal to that other option of 246.44. Okay, I've got that answer, the 246.44 in my calculator. I'm going to divide by 30 to undo the times by 30, so that gives me my t minus 5 being equal to 8.2, roughly, 215. And then I'm going to add 5 to both sides, and that gives me 13.2. So t is approximately equal to 13.2 there. Okay, and that's in hours, so that would be like 1 in the afternoon plus 0.2 of an hour. I'm going to take, oops, okay. Now I'm going to work with that other one, 66.44. negative. I'm going to divide that by 30, and that's going to give me negative 2.21 roughly, and that's going to equal my t. Take away 5, I'm going to add 5 to that, and that's going to give me roughly 2.8, 2.785, 2.8 is my time. So that's in hours. So the 2.8, looking at that, is probably this answer over here that's close to my 3. I do have this other answer, but notice the 13.2. 13.2 is probably this one right here. If I subtract the period from the 13.2, so 13.2 subtract the period is 12. So 13.2 subtract the 12, that gives me 1.2. So that is probably my first answer right here, 1.2 hours, or 0.2 of an hour would be about 12 minutes. So about 1:12 a.m. So between, I've run out of room, so between 1:12 a.m. and 2.8. So 0.8 times 60 minutes. That's 48 minutes. So between 1:12 a.m. and 2:48 a.m. it is unsafe, as well as, of course, 1:12 p.m. and between 1:12 p.m. and 2:48 p.m. and also between 1:12 2:48 p.m. It would be unsafe. Okay, and this is our example number 3. This time I'm going to let you figure this out. Put the video on pause, see what you can come up with, and then check your work. Okay, so hopefully you've tried your hand at this question. I've made a couple of typos on my copy of this, but hopefully your copy will be okay. This is in feet, not in meters, otherwise we're going awfully incredibly fast rotating speed on this, and this is a 20 here. The period ends up being 20 seconds. It takes 20 seconds for the Ferris wheel to make one entire revolution. When I sub x being a 5, that's replacing my time with the 5, and I get 35 feet above the ground at 5 seconds. And at x equals 0, that's time of 0. So the start of when his height is being tracked, the rider has a height of 20 feet. So he's even with the axle of the wheel. Determine the time it takes to reach a height of 13. So I put the height in as 13, and I'm solving for x. When I get to the point where I do inverse function sine, so at this line I'm going to do inverse function sine. I'm using the cast rule here to help me get my 2 angle values. So I end up with the angle being negative 27, or I can do 360 minus that 27.82, and that is where I've come up with 332.2, and then I'm dividing both sides by 18 to get one of my times of about 18.45 seconds. The height would be 13 meters, so about 18.5 seconds. And then my other angle is in that third quadrant, so 180 plus that extra 27.82, the related acute angle, and then divide both sides by 18, and I got about 11.5 seconds there. So he's reaching a height of 13 meters, 11.5 seconds into his ride, as well as 18.5 seconds into his ride during that first revolution.